This is where simulation becomes not just useful, but essential. Hello all. Today, I'd like to talk about how CADFEM is playing a pivotal role in enabling simulation-driven product development in the field of optics and photonics across commercial industries, academia, aerospace, and defense sectors. As we know, optics and photonic technologies are at the heart of many modern innovations, from imaging systems and sensors to laser technologies and optical communication. However, designing and optimizing such systems is inherently complex. It involves the interaction of light with materials, thermal effects, structural deformation, and at times electromagnetic behavior of all sorts. This is where simulation becomes not just useful, but essential. CADFEM, as a long-standing partner and solution provider in the simulation ecosystem, is helping organizations shift from traditional trial and error approaches towards a more predictive simulation-driven methodology. By leveraging advanced multiphysics simulation tools, our organization enables engineers and researchers to model real-world optical phenomena with high fidelity before physical prototypes are built. In the commercial sector, this translates into faster product development cycles and reduced costs. For example, companies developing optical lenses, LED systems, or photonic devices can simulate light propagation, scattering, and thermal effects early in the design process. We support these efforts by providing not only the software platforms, but also consulting expertise and customized workflows. This ensures that organizations can confidently optimize performance, improve energy efficiency, and meet stringent quality standards. In academia, CADFEM plays a crucial role in bridging theory and application. Universities and research institutions often work on cutting-edge optical technologies such as metamaterials, nanophotonics, and quantum optics. We enable researchers to validate theoretical models through simulation, explore design variations rapidly, and gain deeper insights into complex physical interactions. Moreover, by equipping students and researchers with industry-relevant tools, we are helping them prepare next generation of engineers for real-world challenges. When we move to aerospace and defense, the importance of simulation becomes even more pronounced. Optical systems in this domain, such as surveillance systems, satellite imaging payloads, laser-based communication, and targeting systems, must perform reliably under extreme conditions. This includes high temperatures, mechanical vibrations, and harsh electromagnetic environments. CADFEM supports aerospace and defense organizations by enabling robust multiphysics simulations that account for these conditions. Engineers can evaluate how thermal expansion can affect optical alignment, how structural deformation impacts image quality, or how environmental factors influence system performance. This significantly reduces the risk of failure and ensures mission readiness. Another key aspect of our contribution is its focus on integration and digital continuity. Rather than treating optics, thermal, and structural analysis as separate tasks, we promote a unified simulation approach. This holistic view is critical in photonics, where even small changes in one domain can have significant impacts on the overall system behavior. Furthermore, we provide training, technical support, and best practice methodologies, helping organizations build internal simulation capabilities. This is particularly valuable for teams transitioning from conventional design methods to simulation-led innovation. We are not just enabling simulation, we are also enabling better decisions. Across commercial industries, academia, aerospace, and defense, it empowers organizations to innovate faster, reduce development risks, and deliver high-performance optical and photonic systems. As the complexity of technology continues to grow, simulation will become even more central to product development, and CADFEM will remain a key enabler in this journey. Thank you.